Got another exam question walkthrough for the titrations topic. So we're up to number 14 now. If you want to check out the other videos in the playlist, I'll put the link to that at the top of the screen now. Hope you like the video, hope you find it helpful, and if you haven't already subscribed to the channel, I'd love you to do so. But as always, the link to the questions in the description of the video if you want to try it first. Okay, so make a start. So what's the difference between a strong acid and a weak acid? Strong acids are fully dissociated or ionized, you could say. Weak acids are partially dissociated or ionized. Moving on to part B, so we've got all this information about this experiment that's been carried out to work out the composition by mass, percentage composition by mass of ethanoic acid in a descaler. But the first thing we've got to do is complete the table of titration results for the three titers. So obviously we're just going to take the initial reading away from the final reading. So there's the three titers there, but you've got to be really careful with this one because obviously your calculator is just going to say 24.4. That 0 needs to be there. Next part, we've got to calculate the mean titer to the nearest 0.05 cm cubed that we're going to use for the analysis of the results. So there's the three titers again. And we're looking now for the concordant results. So we're looking for results that are within 0.1 cm cubed of each other. So you can see 2 and 3 are concordant. So we're going to have to ignore result number 1. So that means the mean titer is 24.20. Do not forget the 0. Moving on to the main part of the question now, where I've got to calculate the percentage composition by mass of the ethanoic acid in the descaler. So I've got my usual diagram here just to visualize what they've done in the experiment. So they've taken 6.5 grams of descaler, dissolved it in some water. They've made it up to 250 cm cubed in a volumetric flask. They've then taken a 10th out, so 25 cm cubes come out. It's gone into a conical flask and they've titrated it with 0.2 moles per decimeter cubed sodium carbonate solution, and we've just calculated the mean titer at 24.2 centimeters cubed. And I just want to stress this line here. Assume that ethanoic acid is the only acid in the descaler. Okay, so the first thing we're going to do is work out how many moles of sodium carbonate were in this mean titer. So that's obviously concentration multiplied by the volume, but we have to have it in decimeters cubed. So we've got that many moles of sodium carbonate in the mean titer. We're now going to use the mole ratio in the equation. So we'll just get back to the equation. There it is there. So we know the moles of sodium carbonate, so we're going to double to get the moles of ethanoic acid that were in that 25 cm cubed used in the titration. So that's coming out at 9.68 times 10 to the minus 3. So the next thing we need to do is scale up to 250 centimeters cubed. So we're going to multiply by 10 because we want to find out how many moles are in here, which are going to be the same as the moles of ethanoic acid in that 6.5 grams of the descaler. So that's going to be 9.68 times 10 to the minus 2. So now we can work out how many grams of ethanoic acid are in these moles just by multiplying by the MR of ethanoic acid. MR of ethanoic acid 60, so that's coming out at 5.808 grams. All we need to do now is divide by the 6.5 grams of descaler, multiply by 100, and that'll put it into a percentage. So there's the calculator value there, but the question did specify that we had to give our answer to 3 significant figures. So it's going to be 89.4.